Hello, we are Aquaterex. We find water where others say there is none. We use a scientific approach to supplemental groundwater location for agriculture. In addition to other challenges, many farmers and ranchers are facing unprecedented water shortages that impact the very existence of their families and business. As the backbone for the world's food supply, lack of water threatens our survival as we know it. If you were to pay attention to what the news services from around the world are saying, no doubt, you would be inclined to think, there is nothing that can be done about it, except to wait for rain.
A summer of record-breaking heat is drying up rivers across Europe. Around half the continent is facing an unprecedented drought.
It may look like a desert, but it's not. What you're looking at is a reservoir in Spain, 84% empty. Some parts of the Iberian Peninsula are at their driest in 1200 years. 63% of land in Britain and Europe is facing drought.
In China, authorities are battling one of the worst droughts seen in more than 50 years.
The mega drought in the western U.S. is so severe, it's making history.
Maybe you haven't even heard the term mega drought before. So what's a mega drought? Well, a mega drought is a drought that lasts 2 decades or longer, so at least 20 years. And right now we're at year 22. This is the map that shows our current drought. About 95% of the West is in drought.
It is true that shallow aquifers, rivers, and lakes are being contaminated and depleted at alarming rates. Together with global, extreme weather conditions, relying only on shallow aquifers and surface water is an outdated model. And as a result, we are feeling the impact of the misconception that there are no other solutions. Yet, new technology to precisely locate and access deeper alternative fresh water supplies is here today. And the most encouraging news is that there is abundant deeper alternative freshwater supplies. The U.S. National Groundwater Association estimates there is 6,000 years of freshwater supply in the upper 2 kilometers of the Earth's crust. Aquaterex has developed the technology to locate and economically bring to the surface these previously untapped water resources. Deep-seated water. It is an almost unlimited alternative source of water. Deep-seated water, or DSW, is high-quality groundwater, typically sourced from deeper aquifers. Such deep aquifers are supplied not only from local catchment basins, but also by subsurface inflows across basin boundaries. Deep-seated water also includes water created at the mantle level of the Earth, under extreme heat and pressure. Although this freshwater source may be located deeper than shallow aquifers, new technology enables us to locate the fractures, channels, and pathways that allow us to access the deeper water, without having to drill wells thousands of feet deep. Thus, this water can be made available economically and easily. With the combination of technologies available to Aquaterex, we can locate water with near 100% accuracy. The benefits of deep-seated water are: it is an alternative source of fresh water for drought-stricken areas. It complements existing water conservation measures. Protects against contamination or pollution. Permits shallow aquifers to recharge and restores surface water. Reinforces sustainable water management and security. Economical, fast, and scalable. And deep-seated water can be located, and water-producing wells can be completed within just a few months. Deep-seated water is the missing piece in your water strategy. Many water strategies focus on conservation, rather than additional supply. Other solutions such as desalination and wastewater treatment are potential answers for some, but they also come with trade-offs such as high cost, high energy usage, long planning periods, and toxic waste. Deep-seated water is abundant, fresh, accessible, and it can be added to your mix of solutions as a supplemental freshwater source that is not subject to pollution. It is fast and easy to implement and is economical and scalable. Exploration techniques for locating and extracting metals, gas, oil, and other minerals, have advanced dramatically over the course of the past century, with well-established operating standards and procedures across these industries. However, the technologies and methodologies for the detection and exploration of groundwater have not progressed at the same rate, and therefore have not been proven to be significantly reliable and economical. Indeed, a large percentage of water locators still use water witching or dowsing to try to find water. That's why the reported success rate of finding water in arid regions is less than 40%. Aquaterex has invested heavily into research and the scientific approach to detect and locate freshwater in arid and semi-arid regions. Aquaterex possesses a unique geospatial data analysis and assessment method for the mapping, locating, and extraction of high-quality, high-quantity freshwater. In fact, the success rate of our technology is over 90%. High-tech advancements give science-based certainty and accuracy on where to drill, and where not to. The technical process of location and extraction of deep-seated water spans several different fields of science and engineering technology. The 4 basic steps are as follows. Step number 1. Acquire remotely sensed geospatial data. Remotely sensed geospatial data is acquired via satellite and airborne geophysical surveys. This includes satellite imagery, magnetic, gravity, gamma ray, radiometric, digital elevation datasets, atmospheric, geology, hydrology, regional water well data, and historical data sets. Groundwater location, step number 2. Processing, integration and analysis of data sets. The geospatial data sets obtained in step 1 are then processed, integrated, and analyzed with geographic information software systems using a variety of proprietary techniques. These unique methodologies allow for the detection of shallow and deep groundwater systems and result in identified areas of interest for field surveys. Groundwater location, step number 3, on-site field survey. An on-site field survey and inspection is conducted by the Aquaterex team. The field survey is conducted to verify and validate the findings of the remote analysis, allowing for the accurate identification of exact locations for bore sites within 1 meter. This includes the deployment of seismic and electro-resistivity measurement devices to map underground structures and locate water. This unique combination of remote analysis and on-ground survey information significantly improves the chances of finding water. Groundwater location, step number 4, time to drill the well. With the scientific data to hand, you now know where to drill. No guesswork, no witching, dowsing, or divining, just pure science. Well drilling costs and effort will vary greatly depending on the location, geology, size, and depth of the well. In some cases, for example, it will require drilling rigs with a capacity to drill through hard rock. Aquaterex can provide and manage the drilling process, or work with your preferred drilling contractor. Over 1,500 deep-seated water wells have been completed on 4 continents. Aquaterex is a global environmental services organization with a mission to broadly implement effective water and food security solutions. Simply put, we specialize in finding water, even where others say there is none. We offer a free consulting service to explore how we can help solve the freshwater challenges of municipalities, agriculture, industry, and developers. Thank you for watching our presentation. Please contact your Aquaterex representative for further information about this or any other service we can help with.